So this is case 3 of algebraic substitution. So if the integrand contains x raised to the power of p times a x raised to the power of n plus or minus b quantity raised to the power of q over n. So the one with the fractional power is this binomial where m and p and q are integers. So meaning q over n is a fraction and then m is greater than 0. So the binomial here must be at least a linear no function and p plus 1 is a multiple of m. So for the function outside the one with the fractional power, so if you add 1 to its power, okay, meaning p plus 1, it should be a multiple of the power of the x term here. So for example, we have x cubed, okay, times 4 plus x squared, quantity raised to 3 halves. So all are integers. We have 3, 2, and 3, and 2 for the q over n. And then p plus 1 must be a multiple of the power here of x. So 3 plus 1 is 4. And then 4 is a multiple of 2. So therefore, we can use this substitution that u be equal to the nth root of the function being raised to a fractional power. Okay, so let me write those values M, P, and Q, M, N, P, Q in alphabetical order. So, para klaro, no? So, M, again, is the power of the function inside the parenthesis, no? The one being raised to a fractional power. And then N is the denominator of the fractional power, so meaning 2. And then P is the one outside, no, the power of the function outside this function being raised to a fractional power. So it's 3 and q is the numerator of the fractional power. So it's 3. So all are integers. M is greater than uh, 0. Okay, and p plus 1. So p plus 1 is 3 plus 1. So it's a multiple no, of the 2 here. Okay, because this is equal to 4. So we use u no, equal to nth root, so meaning square root of the binomial being raised to a power of 3 halves. So it's 4 plus x squared. And after solving for u, or setting the u rather, so we solve for x. So we need to um, square no, the entire equation to remove the square root on the right side. So the right side becomes 4 plus x squared. And then solving meant for x. So we need to put the 4 to the other side of the equation. So therefore, x squared equals u squared minus 4. And x, therefore, is square root of u squared minus 4. Okay, or we can write it in this form no, instead of the radical para it would be easier later to perform operations involving this fractional power now of x squared minus or u squared minus 4. And then after solving for x, solve for dx so that we can replace the x's no, in the given integrand. So dx, therefore, using power rule, we have 1/2 no, times u squared minus 4. And then we need to raise this to n minus 1 because we're doing differentiation. So 1/2 minus 1 or negative 1/2. Then don't forget to multiply it with the derivative of bali the base. No? So derivative of u squared is 2u. And then simplify. So we have u no, times u squared minus 4 quantity raised to the power of negative 1/2. And don't forget the du. So we can now transform all the x's here no, to functions of x or functions of u rather. So we have x cubed. So x is this u squared minus 4. Okay, quantity raised from 1/2. So we need to raise it no, to a power of 3. So let me change the color para claro. So this is the value of x and then raise it to a power of 3. That's for x cubed. No, this is equal to x. So we need to raise this to a power of 3. And then 4 plus x squared. So we have 4 no, plus x squared. So x squared from here is u squared minus 4. Then we need to raise this to a power of 3 halves. Okay, again, the u squared here is the x squared and then the dx. So this step is not necessary. So if you can right away express the x cubed as u squared minus 4 quantity raised to the power of 3 halves no, because we have 1/2 times 3. So write it na lang. No? So this is for, of course, discussion purposes. That's why we are writing everything. Okay, para explain yun in detail. So we have dx u times u squared minus 4 raised to the power of negative 1/2 d. So we have u times u squared minus 4 raised to the power of negative 1/2 and then the du. So the goal here is to express no, all the powers as integers so that we can apply na the different integration formulas. So we have 1/2 times 3, power of a power rule. We multiply the powers. So this is equal to 3 halves. And then 4 plus u squared minus 4, that's u squared. And then raised to the power of 3 halves. Okay, so that's u squared. That raised to the power of 3 halves. So that's 2 times 3 halves, or that's 3. Okay, so it's u raised to the power of 3 or u cubed. And then times the u, then times the u squared minus 4, quantity raised from negative 1/2 du. So combine all those functions that you can combine. So starting off with the u's, so we have 3 and 1, so that's u raised to the power of 3 plus 1 or 4. And then we have u squared minus 4. So 3 halves for the first function. Okay, and then we have negative 1/2. So 3 halves plus negative 1/2, that would be equal to 2 over 2, no? Or meaning 1. Okay, so let me write na lang that. No, 3 halves yeah, minus 1/2. And then, of course, the du. So we have u raised to the power of 4. And then u squared minus 4, quantity raised to the power of 2 over 2, or that's equal to 1. And then du. So the result, okay, is no? The powers are now expressed as integers, so we can now easily integrate. So we have u raised to the power of 6 minus 4 u raised to the power of 4, okay, u. So integrating using power formula. Okay, so we have u raised from 7 over 7, or that's 1 over 7. U raised to the power of 7 minus, okay, that's 4 no, over 5. U raised to the power of 5. And then, of course, plus c. And don't forget to return, okay, the x variable. So we have 1/7 Okay, u is square root of 4 plus x squared. Okay, or that's 4 plus x squared, no, quantity raised to the power of 1/2. So this can be written as 4 plus x squared raised to the power of 1/2. Para again, easier no to um raise no to a power of 7. Okay, mas paro no na instead of kaning radical, so we use na ng fractional powers para sa yun inig kuha nimo sa raised to the power of 7. So u is 4 plus x squared, quantity raised by 1/2, and then raise it to a power of 7. And then minus 4/5, okay, times same thing, 4 plus x squared raised to the power of 1/2, and then quantity raised to the power of 5, then the plus c. So we have 1/7, okay, times 4 plus x squared, quantity raised to the power of 7/2, and then 4/5 times 4 plus x squared raised to the power of 1/2 times 5. So that's 5/2 plus c. So this is the final answer. So that's 4x raised to the power of 3, okay, times 4 plus x squared, and then quantity raised to the power of 3 halves dx. Okay, so this is the final answer. So, in some references, no, in some books, okay, so their answers are bale factored out because we have here a common factor, no? They are both 4 plus x squared, okay, ang iyahang base. So there's a common na factor. So para when you compare your answers with the answer key, so dili masyok og ngano na na. No, so let me insert another way of writing the answer. Okay. So let me start off with the this part wherein we have the u no na variable instead of the x, para it would be easier to get no the common factor. So ato insert ha. So alternate solution, okay, would be factoring out u squared. Okay. So from that, so sikat na to bale no at this point. Or let me write at this point at A. So we factor out the common factor, no, which is use raised to power 5. Okay, so we need to multiply it with 1/7 u raised to power 2, and then minus 4/5 times 1, no, or 4/5, and then the plus c. And then usually, okay, especially for the reference book that I'm using, no, by Engineer Rosalan and Engineer Fararen. So their final answer is expressed as any combining no the two terms. Okay, so we have 7/5, no, the LCD is 35. So 35 divided by 7, that's 5 times u squared, so 5u squared. And then minus 35 divided by 5 is 7 times 4, so that's 28. And then plus c. Okay, and then you go back to the variable x. So u again is 4 plus x squared raised to the power of 1/2. So that would be equal na to 5 halves, no? For the power. Okay. 5 una. And then for the one inside, so 5 times, so u squared is 4 plus x squared lang, no? So this one, 4 plus x squared times 4 plus x squared, and then minus 28, and then all over 35. And then simplify pa good further. So that would be 5 halves. And then, so we have 20, no? Plus 5x squared minus 28. Okay, over 35. And then the plus c. So we have this. And then 5x squared minus 8 all over 35. Ay, and then plus c. Okay, so you can have your answer expressed as this. Okay, removing bale or factoring out na the greatest common factor. So equal na yun na ani. Okay, so alternate bale solution. So if you are using trigonometric functions for the integrals, so if you compare your answers, no, so dili gani pariha sa answer key, meaning okay, you need to use trigonometric identities. So if it's algebraic function, then use the power, okay, or rather the laws no, of exponents. So that's for case 3 no, of algebraic substitution.